1980s, Charles Nam had more time once again to return to large-scale demographic research projects. At the start of the decade of the 1980s, Ike Eberstein also joined the FSU Sociology Department. This provided the collegial connection that enabled Charlie to extend his research on survival and mortality to consider in detail the sociological dimensions of patterns in infant deaths. Nam and Eberstein reached out to physician and medical expert on infant and child health, Dr. Larry Deeb, and to FSU technical researcher Walt Terrie. Together, this new research team prepared a grant proposal to study infant survival and submitted it to the National Institutes of Health. After rigorous peer review, the grant was approved in 1986. This article was one of the first publications to emerge from the project.
In the mid-1980s, Ike Eberstein and I received a substantial grant from NICHD on the topic prior and proximate factors in infant mortality by cause, taking the birth certificates for the state of Florida from 1980 to 1982, which included over 400,000 births, and linking those records to the any infant deaths that occurred for these births.
The linked birth death file from 80 to 82 was produced by the Florida Department of Health, the Florida Biostatistics. What we did was merge, like Charlie said, we merged the infant death certificate records with the multiple cause of death file that was produced by NCHS. So we took what the Florida Department of Health provided, and then we added the multiple cause of death information to the death record.
Once the grant project was launched, the research team expanded to include several graduate students, including Bob Hummer, whose dissertation research, chaired by Eberstein, was also based on research related to the grant.
Bob Hummer was a graduate assistant at the time for both Ike and me, and was assigned to this project. And it turns out that Bob Hummer, who is now on the faculty at the University of North Carolina, did his doctoral dissertation using these data. And then subsequently we brought Larry Deeb in to confirm certain medical aspects of the data.
Hummer eventually became the president of the Population Association of America in his own right. Infant mortality research already was well established as a demographic concentration by the mid-1980s, so the research project was building on a substantial existing literature. The innovative focus that convinced NIH reviewers of the merit of the proposal centered on causes of infant deaths recorded on Florida death certificates for several years in the early 1980s, compiled by the National Center for Health Statistics. More specifically, the research team aimed to compare conventional reliance on what reporting physicians listed as the direct or immediate underlying cause of death on these death certificates and additional information also recorded there about other contributing causes of death. Incorporating all of this cause information from death certificates for infant deaths had not been done before. Nam and his colleagues hoped to uncover new insights into determinants of infant deaths with this research.
Most cause of death analysis uses the underlying cause of death, which is what the physician responsible for recording the information about the death assumes was the cause, the medical cause that initiated sequence of events occurred. So we had the underlying cause of death on the record, but we added three different combinations. One was what we called total mentions. Any medical condition was mentioned on the death certificate, whether or not it was designated as the underlying cause. Then there was the principal diagnostic cause, which is characterized by the typical priority in a physician's medical diagnosis. And lastly, cause combinations, which is the configuration of those conditions mentioned on the death certificate.
Starting from what doctors write down on death certificates, over many years, researchers have learned to distill some manageable categories for grouping literally thousands of different diagnoses listed as underlying or contributing causes of death. Infant deaths normally are attributed to only a fraction of all possible causes, but still, Nam and his colleagues were faced with the task of adapting existing cause categories to their own research strategy.
Although for adults, particularly senior people, there are a number of medical conditions that would be cited on a death record. In the case of infants, in our data set, there are between 2 and 3 conditions mentioned. So we had that, much fewer, but significant.
And so what we have is two basic cause schemes. One of them, the principal diagnostic syndrome, takes some conditions like immaturity. I think that was the number one.
Extreme immaturity.
Extreme immaturity is clearly obvious. And so that would be, from a diagnostic point of view, pretty high on the list of things. Then also, we tried to consider, and that we use the term lethality, which, and these are all causes of death, and these are all infants that have died. So we're trying to approximate, I think, the concept of case fatality, where we have no denominator data. All we have are numerators. So we're trying to approximate that. And so we combined that, the diagnostic certainty with lethality. I hate that, but that's the only thing we could use to put them together, and that's the ranking. And we have 10 cause categories that we've created.
In the end, they decided on 10 categories for describing why Florida infants had died. The first category, extreme immaturity, refers chiefly to deliveries at such short gestational ages when fetal development was so incomplete that survival became almost impossible. A second category identifies congenital anomalies such as monosomies, trisomies, and other genetic abnormalities that pose serious survival risks. A third category, respiratory distress, often reflected incomplete development of fetal lung tissue and resulting impairment of an infant's ability to breathe. Additional categories included external causes of death, such as accidents, other perinatal events, such as entanglement with the umbilical cord or difficulties with a breech birth, and a category for respiratory infections and other disease conditions acquired after birth. The category of prematurity generally refers to a later gestational age than for deaths from extreme immaturity. This can include problems such as newborns who are smaller than normal for their gestational age, premature deliveries brought on by non-lethal issues like intrauterine infections, and other gestational issues. The research team also added a small catch-all category for other very rare and unusual causes listed on certificates, and finished with the most mysterious category of all. When doctors certifying an infant death could find no certain cause, such as an infection, extreme prematurity, an accident, or any other identifiable underlying cause, they had to throw up their hands and simply attribute the death to sudden, unexplained causes, a category that came to be labeled as Sudden Infant Death Syndrome, or SIDS. Consider the standard pattern shown here in red for reported causes, based on the underlying cause from the death certificate. The leading cause of these Florida infant deaths was perinatal events related to labor and delivery. The two categories of congenital anomalies would rank second if we combined them, with respiratory distress in third place. However, if we look at the blue bars in the figure instead, the pattern changes slightly. The blue bars reflect an alternate classification based on additional information on the death certificates in addition to the underlying cause. From this perspective, the chief culprits leading to infant death shift to the two combined categories of congenital abnormalities in first place, then extreme fetal immaturity at the time of delivery, and perinatal events surrounding labor and delivery only in third place. In both ways of classifying infant deaths, though, all these leading causes concentrate in the earliest hours and days following birth, known as the neonatal period. In this second figure, also based on Table 1 from the article, the cause categories are regrouped. The first four cause categories on the left consist almost entirely of neonatal deaths. Almost none of them occurred after the first 28 days following birth. In the middle of the chart, the two categories of congenital anomalies also are dominated by neonatal deaths, but a significant share of these deaths also extended past the first month of life in cases where such anomalies were not immediately lethal for a newborn. Finally, the last four cause categories include accidents, infections and other causes, as well as the mysterious SIDS category, where no specific cause could be identified. These show very different patterns. Almost all such infant deaths occurred only after the first month had passed and babies had lived for some time in their home settings. These causes, showing the effect of socioeconomic influences, were of special interest to Nam and his colleagues. Ike Eberstein explains the importance of these cause categories.
The way I look at this is what we were trying to do was to chart out the links between social position and death, with the idea, and I'll be maybe speaking more personally now in terms of a theoretical perspective than one that's shared, that social inequality is a real important characteristic in the lives of infants and their parents. And thinking about what social inequality means, probably the ultimate inequality is differential mortality. And in this context, knowing exactly what infants die from is critical. Underlying cause is one way of looking at it. It's the locomotive, that starts the engine, right, or whatever, pushes or pulls, whatever analogy you want to use. And then different ways of approaching that, looking at the death record, you have more information.
In addition to cause of death information, the infant death certificates also included some information about the social circumstances of the baby's mothers. For example, birth certificates report educational attainment of mothers, and the researchers found a clear survival difference for the births to mothers who never finished high school compared to more educated women. Risks of death also were higher for births to black mothers than to those of other races, to women who were not married at the time of the child's birth, and to women having babies before the age of 20 compared to older women. Results published by Nam and his colleagues in Table 2 of this article allow calculation of how much higher the risk of death was for infants whose mothers appeared in each of these social risk groups, shown here separately for the two congenital anomaly categories combined in blue. For causes appearing almost entirely during the early neonatal period in green, and finally for causes appearing mostly only after that first month in the remaining 11 months of infancy, the four causes mentioned above as a socially influenced causes. The first clear result in this figure is that lethal genetic flaws play only a very minor role in higher infant death rates for women in the high-risk groups. These congenital anomalies are not completely random, but they are almost as common for women outside the considered risk groups as for the women who were dropouts, black, unmarried, or still in their teens. All of the blue bars in the figures are greater than even odds of 1-to-1, but none of them rise as high as for other causes. For the causes that strike quickly during the neonatal period, the story is not as consistent. These other neonatal causes concentrated slightly more among teen mothers and those who dropped out of high school than among older or more educated women, but the green bars for these two risk groups are only a little higher than for the blue bars based on congenital anomalies. In contrast, infant deaths from causes striking quickly during the neonatal period were between 2 and 3 times higher for women who were black or unmarried than for women of other races or who were married. For these two risk groups, the relative risk of a neonatal infant death was almost as concentrated among women in these groups as for the risk of a post-neonatal death from causes more commonly linked to social conditions. Finally, risk of infant deaths for socially influenced causes, found mostly in the post-neonatal period, such as accidents and the mysterious SIDS diagnosis, was between 2 and 3 times more likely for women in any of the considered risk groups than for other women in more advantageous circumstances. The figure shows the same pattern whether we look only at the underlying causes of death recorded on the birth certificate or consider the alternative principal diagnosis approach that considers additional related contributing causes. Both measurement approaches tell the same story of different life chances for newborns of mothers with different life contexts, a difference that is slightly visible even for causes of death like congenital anomalies, but that concentrates infant deaths more and more among the most disadvantaged mothers as the lives of infants extend further and further out into the post-neonatal period of that first year of life.
And, in Florida in 1982, the disparity in the ability to deal, for example, with respiratory distress syndrome. One of the small hospitals in North Florida, born in Jackson Memorial, there was a moment in Tallahassee when there wasn't a neonatal intensive care unit.
If you were extremely premature and had hyaline membrane disease and couldn't breathe and turned blue,
you're done. The
research project resulting in this article, launched almost 4 decades ago, helped to lay the groundwork for a growing body of empirical evidence of inequalities in that most basic of life chances, the chance simply to stay alive. Despite the intervening years and expanding scientific literature, disparities in survival chances for infants with mothers in different social contexts continues to pose an ethical and practical policy challenge in American society. The patterns discovered in this article remain largely unchanged today, despite overall progress toward increased infant survival. Charlie Nam and his colleagues were among the earliest scholars to address the problem, but we still have not found the solution.